Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
So let's see if we can figure out what a position time graph tells us. There's a lot of really cool things about this. And so in our doodle notes, you'll notice there's some really interesting places to draw. The first has a reference to this spot, and this spot. And what you'll notice is that when you are flat, you're not moving. So when you have a slope, right, this is all about slopes, the slope of 0, then you have complete stoppage. So you should write that down in your doodle notes. And let's actually back up for one more thought here. There's this thing called tangent line. The tangent is the slope at a particular point on the graph. So the slope here is 0. And the slope, if you've got a curve, the slope is this, or it could be this. So it depends. The slope changes when you have a curved line. We'll talk about that when we talk more about acceleration. So let's describe what's happening here. So point 1 right here, also point here and point here, these are points where the person is stopped, or the object is stopped. Between here and here, what's going on is the person is accelerating. They're going faster and faster and faster, because if you think about it, the slope is this, and then it's this. It's getting steeper. Make sense? And then as we get to this point, I'd say about right here to here, what's happening is now, and you should be writing this down, is that this is a constant, this is a straight line. So this is called constant velocity. Again, they're stopped. Now here's the interesting one. They're accelerating, but they're now going in the opposite direction. Notice this is to the east, so that means they're going to the west. But they're getting faster going to the west. And then the slope goes back this way, so it's more positive in the negative sense. That makes sense. Here they're slowing down, stopped, and then they travel, if you will, now to the west at a constant speed, because this is a straight line, and then they stop. So let's now see if we could tell a story. Story time. Story of what happened. So let's say that you are making a plan to make a trip to your favorite ice cream store, which happens to be to the east. So you think about ice cream. Oh, ice cream, ice cream, ice cream. I want ice cream. But you stay at home for 10 minutes. But then you get on your bicycle. And stage 2, you accelerate, you go faster and faster and faster. And then you, up until this point. But then you reach a point where you're now at constant velocity. Now you're going at a particular speed, a constant speed. So it took you a while to get up to speed, but now you can just go at a constant speed. You get to the ice cream shop, you spend some time there, maybe 20 minutes, and you have your cone. Oh, that's nice. Then you get back on your bicycle, and you start pedaling fast in the negative direction. That's back to the west. And then you start slowing down. It takes you a little longer to slow down. Maybe your brakes don't work so well, right? Again, writing this down at the bottom, this is the steps, right? And then you get home and you take a 10-minute break. Oh man, that was kind of a hot day here in Houston and I need to take a break. But then your mom says, hey, let's go somewhere else. But it's now to the west. So you hop in a car and you go to constant speed for, 20 or 30 minutes to get to the bookstore, let's say, because books are awesome, right? And then you sit at the bookstore and read and you don't move. So copy that down in the doodle notes, and that will help you to understand, map out what each region means. Flat, accelerating, constant velocity, stopped, accelerating in the opposite direction, decelerating, stopped, constant velocity in the opposite direction, stopped. So how do we interpret, Houston, these graphs are telling us so much about how we move and how things move. So let's talk about how we can interpret the graphs. We've got 4 cases, actually 8. We got the positive direction and the negative direction. So if you're stopped, all right, let's just say we've got stopped positive, and this is stopped negative. So let's think of a picture, right? We've got a cat here, a character, and the character is starting here, all right? So this is a person. This is the reference point. And here, they're just stopped. They're not moving. And this is the same thing. At the reference point, they're stopped. They're not moving. So you could just have them here, maybe draw the second picture, standing, right? But they're standing at the reference spot. All right, that's easy for stop. But constant velocity is an interesting one. We could have a graph that looks like this, or we could have a graph that looks like this. So those are 2 different cases. So if we were to draw our picture right here, all right, then the pink person, all right, there's our reference point, we won't draw that, but the pink person we'll put right here because this person is traveling faster, fast, than the green guy. The green guy, from the reference point, is also traveling, but not as fast as because the slope determines that, right? Now, what about if you're going in the negative direction? In this case, it's just simply the reverse. You come down here, right? You're going, notice it's a negative slope, and maybe here we've got somebody who's going faster. That's a greater slope. So in this case, if this is the reference point, what you essentially have is the pink guy is moving at a constant velocity, but now back to the west, and he's going pretty fast, where the green cat is going, and he could be right here too, it could be at the same spot, I guess, but he's traveling at a slower speed back to the west. Now, speeding up is interesting. Let's draw a couple of graphs. It could be like this, or it could be like that. And here you can't get a specific slope because the slope changes. That's what this whole business is about. And there, in this case, our cat would be moving in this direction in an increasing, if you will, speed. He's getting faster and faster and faster, and that's we call acceleration later on that. In this case, what if I'm speeding up in the opposite direction? It looks like this, right? Yeah. Sorry, I had to look at my notes there. Or like this. And of course, in this case, what happens is the person is over here, and they're speeding up back from the west to the east in our picture. So what does slowing down look like? It's going to look more like this or like that. So that's a slowing down. So here we have a person. Now they're still moving, all right? So our person is, from our reference point, they're moving. What they're doing is they're getting slower and slower. So they're going at 10 meters per second, and then 9, and then 8, and then 7, and they're starting to slow down. Think about the end of a hard run, and you're going fast, and then all of a sudden you start to slow down and slow down and slow down. But this would be to the east, and this, of course, would be the exact same thing, except for going in the opposite direction, getting slower, 9 meters, negative 9 meters, negative 8, negative 7, negative 6 meters per second, something like that. So why is this important? This is because when we start looking at these distance time graphs or position time graphs, we can learn so much just by understanding the slope of the line. Flat is stopped. Constant velocity is a straight line. That can go two directions, right? Constant velocity one direction or the other. And if we are speeding up, it's a positive sort of slope, if you will, that leads up and up and up, or up, down and down and down, depending on what direction you're going. And if you're going to sort of a flattage area, that's when you're slowing down. Look at what's flat going up or flat going down. Hopefully this helps you to understand the amazing kinematics of physics. Thanks again to Mrs. Brosseau, our amazing doodler. We'll see you in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.